Good morning. This video is for my Honors Integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure I'm going to title this, but I'm going to title it how I titled the title. But what I am sure of are the questions that I'm going to go over that were from the Unit 1 test. So the first three questions, which are 4, 5, and 6, I'm going to show you how to solve and check them using our 6 steps to solve and how to verify the answer. So if I remember correctly, we actually did solve problem 4 in class, but I'll do it again in this short video. So what I'm going to do is I'm going to list my steps. This is a guide to help me solve my equations. Step 1, can I eliminate fractions by multiplying everyone by the denominator? Nope. Do I have parentheses? Yes, I do. So that means that I can distribute. So I'm going to distribute. I'm going to pass out the 3 to the 2x and the 3 to the 8. So I get 6x plus 24. And I'm going to pass out the negative 4 to the x and the negative 4 to the 5. And here I get minus 4x plus 20. A lot of you on that test, you put a minus there. That was a mistake that was made. Alrighty, so now let's move on to our third step. Can I combine like terms on each side of the equal sign? Can I put anyone together on the left side? No, I cannot. These are not like terms. Same as on the right, they are not like terms, so I cannot do step 3. Step 4, get all variables to one side of the equal sign using addition or subtraction. I have variables on both sides of the equal sign, so I can actually add the 4x to the other side. So I'm going to go plus 4x and plus 4x. My 4x's on the right cancel out, and I'm left now with 10x plus 24. That makes a better x. There we go. And that's equal to 20. So I did step 4. Step 5, can I add or subtract away a number on the variable side of the equal sign? Meaning, there's a plus or minus between the number and the variable. Well, 24 and x are separated by a plus sign, so I can do step 5. And I'm going to subtract 24 to both sides. Now I have 10x equals, I have 20, I owe 24, I owe 4. Can I divide away a number from the variable side of the equal sign? Yes, I can. So I'm going to divide both sides by 10. And I get x is equal to minus 4 over 10. So I have solved it because x is by itself. Now let me check. Everywhere I have an x, I'm going to plug in this value. Now remember, fractions aren't necessarily bad to check if you leave them as fractions and move them around as you would with an x, because eventually this fraction is going to have to cancel itself out. So hopefully I have enough space here. Let's see here. I go 3 parentheses 2 times my answer, which is minus 4 over 10. And to be honest, I don't care if it's negative. It doesn't matter because I'm going to treat it like an x. Well, I guess most x's are negative. So we have 4 parentheses negative 4 over 10 and minus 5. All right. So let's pass out the 3s. We can distribute that. So we're gonna get, and again, just treat this like an x. Just leave it next to the number that is the coefficient. So here I'm gonna have 6 negative 4 over 10 plus 24. And here I'm gonna have 4 negative 4 over 10s. Minus 20. Plus 20, because it was a minus 4. Let me make sure I write the problem down. Minus 4, so that's minus 4 right here. And that's now plus 20. Okay, caught my mistake. Alright, so I'm going to get my like terms on one side. So what I'm going to do is I'm going to add my 4 negative 4 tenths to both sides. It's an odd kind of step to do. But if you just treat it like a variable, you can move it around without dealing with the fraction. All right, so here we have now, I'm going to write the result right up here. Hopefully I have enough space. But now I have 10 negative 4 over 10s. Plus my 24. And that's equal to my 20. Right, because these guys canceled out. Well, guess what? The 10 and the 10 are going to cancel. So now I have minus 4 plus 24 equals 20. Minus 4 plus 24 is 20. And now I have a true statement, which means my answer is correct. So again, you can check fractions by just moving them around, combining them all together, and they're going to cancel each other out. It has to do it. All right. So that's number 4. Number 5. Let's go ahead and jump into that. I'm going to go a little quick. If you need to slow down, you can hit pause. All right. So number 5 here, and actually let me erase this so there's enough room and I'm not getting too crowded here. All right, so can I eliminate a fraction? Well, let's do this first. Let's cover this guy up with my good drawing of a hand, and I'm going to multiply everybody through by 5. You get a 5, you get a 5, and you get a 5. My first 5's cancel, now I have 2x. 2x minus 5x equals to 10. But remember, I covered up a fraction, so I want to bring that back. All right, I got my 3 back, and I'm going to do that step again. Wash, rinse, repeat. So now I'm going to multiply everyone by the denominator, and that's how I eliminate fractions. So fractions aren't really as bad as we might think they are. 3 2x's means I have 6 2x's. My 3 is canceled, so it's 6x minus 5x. 6x minus 5x is equal to 30, because I have 3 10s. Can I distribute? Nope, because there's no parentheses. Can I combine like terms on each side of the equal sign? Yes, I can. So here I get 1x, which is just x, and x equals to 30. All right, let's check our answer here, because we are done solving because x is by itself. So here I have 2 30s divided by 5 minus a 30 divided by a 3. And is that equal to a, I'm making a mistake, I think, for some reason. What's my mistake? I think I'm okay. Okay, and is that equal to 2? Okay, so here I have 2 30s, which is 60. 60 over 5, 5 goes into 60 12 times. 30 divided by 3 is going to get me to 10. And is that equal to 2? 12 minus 10 is 2. 2 equals 2. Oh, hey, I did that right. I had to think there for a minute and nothing was happening. Okay, so that's how I do problem 4, problem 5. Problem 6, it's a curveball. Solve for 3. I want this by itself. I'm going to use those steps. Okay, and again, 1, 2, 3, 4, 5, 6. Can I eliminate fraction? No. Can I distribute? No. Can I combine like terms on each side? No, I can't. Are all my 3's on one side? Yes, they are. Can I add or subtract away a number from the variable side? This is a little tricky. We're not solving for a variable, we're solving for 3. So basically, is there something with a plus or minus between the 3 and that thing, and it's the c. So what I can do is I can subtract the c to both sides. Now I have 5 minus c is equal to 3x. Is 3 by itself? No, it's not, so I have to divide away the x. So we'll just divide away the entire side by x. Now I have 5 minus c over x is equal to 3. We've isolated 3, so we solved for 3. Now we need to check, and what that means is we replace 3 with this entire value. So here we go. We go 5 equals not 3. I'm going to put a parenthesis there, and then x plus c. So in here goes what goes in here. We replace 3 with 5 minus c over x, and now we just untie the knot. X and x cancel out. Now I have 5 minus c plus c, they cancel out, and now I have 5 equals 5. So that means that I have a solution. All right, so I've done problem 4, 5, and 6. I'm going to clean this up, set up problems 7, 8, and 9, and wrap this up. So let me clean all this up, and I'll be back. I'm back. So let's go ahead and finish 7, 8, and 9. Now, I didn't change the steps. Step 7, we graph, but we use these steps essentially to solve this. So again, I'm going to write my 1, 2, 3, 4, 5, and 6. no fractions, no parentheses. I can't combine like terms, and all my x's are on one side of the inequality. But I can add or subtract away a value. I can subtract away the 4. Because there's a plus or minus between the 4 and the x. Now we have 5x is right of or greater than 15. I can divide away the 5. And now we have that the solution is right of 3. Okay, so remember, or the x is greater than 3. It's an open circle because the boundary is not part of the solution. Any number to the right of that will make this true. Problem number 8. Again, we can do it, all the steps at once. This one, I only have to get rid of the minus 3. So I'll make the minus 3 go away. I go plus 3, and plus 3. And if I owe you 9, I give you 3 and tell me I owe you 6. The 3's cancel, and 10 and 3 gets me to 13. Learn how to add, there we go. So this literally says that the shading is between the negative 6 and the 13. Okay, that's what that means. Negative 6. And it's a solution at negative 6. It's not a solution at 13. But any number between that will be a solution. So that's how we graph that one. And on to number 9. Number 9, we solve 2 inequalities and put them on the same graph. So the first thing I do on this one, this is a little one-step one. I'm dividing here, and when you divide, you change the order. When you change the order, you have to change the description. So here it's saying this is on the right of that, but when I change the sign of everything, it now becomes on the left. This one, again, I can add the 7 to both sides. I get 5x right of or at 15, greater than or equal to 15. Divide away the 5. I'm not changing the inequality because I'm not changing the position of the numbers, so I don't need to change the description of the numbers. And we put them both on the same graph. So at negative 3, it's an open circle, and I shade to the left. And at positive 3, it's a closed circle, which means it's part of the solution because it's shaded, and I shade to the right, or at 3. Okay, so that's how I answer the last 3 problems of the test. Hopefully this helps you when we redo the problems that we missed. So I'm going to go ahead and end it here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.